Good afternoon, and welcome to the 5th Annual IDEA Challenge at the SciTech Forum. My name is Christopher Rouw with Ball Aerospace, and I've had the pleasure of coordinating this session with my colleague, Kayla Zweifel. Unlike past SciTech IDEA Challenges, this year is not a competition between teams. Instead, the goals are to give a voice to the new generation of AIAA leaders, enable our young professionals to share their thoughts and perspectives concerning important issues within the aerospace industry, and to collaborate with their peers from across industry, and to create an opportunity for meaningful dialogue between the AIAA community and emerging leaders on critical aerospace issues and solutions. We have 5 teams today that will be presenting their ideas, comprised of industry, government, academic, and international participants. All these individuals volunteered to participate, and until Sunday, most of them did not know each other. Teams are formed based on participants' survey responses for what they felt was an imperative issue to solve within the aerospace industry. As if that wasn't challenging enough, we also put our 5 teams to the test and asked them to develop their ideas within the framework of the value creation methodology developed by Kurt Carlson. If you participated in SciTech 2023, you may have seen the value creation workshop session that Kurt presented with Scott Faust. Value creation approach is a simple framework that encourages rapid iteration. By using this methodology, our teams learned how to create a compelling value proposition that included the following elements: a hook, a need, the approach, benefits and cost, analysis of the competition, and finally, an action. Our teams also used large language models such as ChatGPT, which we've been hearing about throughout most of our other Forum 360 sessions, to assist in their creation for the value propositions. Remember, they've just been starting these since Sunday. The teams have put significant time and effort throughout the week to build their pitches, and I know you're all going to be very impressed. Throughout the past week, we are grateful to have had senior leadership mentors provide guidance and support to our teams. I would like to recognize our IDEA Challenge mentors: Danette Allen, Natalia Alexandrov, Isaac Cohen, Steve Frick, Scott Faust, Lindsay Holmes, John Coling, Kevin Koharki, Brian Kowalczyk, Belima Maged, Caroline Mercer, Michelle Miller, Ricky Shine, and Sean Weil. Thank you to all of our mentors for their guidance and support. We'd especially like to thank Belima with Aptima, as she led the teams through the initial value creation methodology and throughout her support throughout the week. Turning now to the program, we'll have each of our teams come up and present their pitch, followed by a brief Q&A by the audience, moderated by my colleague, Kayla. Please use the QR code that will be appearing across the screens to submit your questions or upvote your favorite questions. We encourage you to think about the presentations and ask questions from the end user's perspective. And now, over to Kayla to introduce our first team.
Thank you, Chris. Please welcome our first team to the stage to discuss alternate powered flight, Team Skyvolt.
From 2020 to 2022, private jet flights escalated from 119,000 to 573,000 in Europe. The majority of these happening in wealthy nations, covering distances under 400 miles, and resulted in a substantial rise of CO2 emissions, over 5 million tons, and large fuel costs for passengers. Now come along with me on a short trip to the near future. It's 2035. Short-range air mobility has rapidly taken off. There are thousands of air taxis and private aircraft running on hybrid or electric propulsion in the national airspace, flying routes in the 300-mile range. Every air mobility manufacturer is racing to get more of their vehicles off the production line, with eager customers waiting with pockets full of money. With more vehicles in operation, service providers and rapid charging infrastructure will be needed. But what is there to do to address this? The solution is Skyvolt, a one-stop comprehensive service provider for hybrid and electric short vehicle aircraft for quick charging or swapping of batteries and repairs. Our services will be provided at public airports and vertiports and Skyvolt-owned locations across the country.
The rise in urban air mobility has attracted a lot of customers for the convenience and the speed of air travel. As more and more individuals and businesses are investing in UAM, there has been a need for charging and maintenance infrastructure. The current infrastructure for UAM is very limited, which leads to delays and inconvenience. So the lack of accessibility and swift services poses a threat to the seamless integration of UAM with the urban commuting. Widespread adoption of UAM into the national airspace may be bottlenecked by the lack of proper infrastructure to support it. So there is a rising need and demand for the charging and maintenance infrastructure, and a provider needs to be ready to be able to offer this kind of service for the vehicle charging and skilled technicians for on-premise vehicle repairs.
And so what is SkyVolt's approach to this? How are we actually going to solve it? What's the value proposition for our customers and consumers? And what is our business model? Well, to drive down and de-risk this for consumers and airports, we look to acquire charging network assets as well as maintenance crew assets in order to provide a service at airports and urban locations for airlines as well as aircraft manufacturers that can use these very expensive services, expensive upfront capital investment services at a cost that is allowing rapid spread throughout multiple different small cities as well as large business hubs to facilitate the adoption of electric and hybrid electric vehicles. The business model for this is quite clear and the need is very evident.
So looking at the current market in electric aircraft charging, there's a big focus on developing small-scale, self-contained charging units. So organizations such as Beta are pioneering this by working with some of the electric aircraft manufacturers. However, there isn't really a consolidated electric aircraft charging service provider. So us at SkyVolt don't really have a direct competition in that sense. This puts us in a really unique position to build relationships with aircraft manufacturers as well as the target destination airports to really cover all of their charging and maintenance needs. As well as this, having infrastructure in place and owning this at key short-haul locations, this will really allow us to onboard some of the hardware suppliers into our supply chain. So we'll partner with some of the suppliers of this technology. Looking into the future, we expect that some of the established electric vehicle charging providers like ChargePoint would enter the aviation market. And this potentially poses a risk for us. However, being an early entrant into the market and having these existing relationships would pose SkyVolt as a leader in the field.
So what's the benefit to you? Not only do we de-risk your switch to electric and hybrid-electric flight, but for the same small distance flight, using hybrid-electric and electric power, you do an 80% decrease in carbon emissions, a 20% decrease in your operating costs, with a 0% decrease in convenience and efficiency of your current methods. So what can you do? We are giving you the chance to seize the opportunity to propel sustainable innovation forward and invest in green technology that promises economic growth while curbing the environmental impact. For our venture capitalists out there, we are promising a minimum 10% return on investment with our business strategy that utilizes cost premiums on our maintenance and battery charging services. For our federal and state government, we asked for you to help us create those partnerships that will allow us to provide this service, allowing you to advocate for eco-friendly technology that will contribute to the reduction in air pollution and carbon emissions. With your help, we can drive a resilient future. Let's forge a path to sustainable progress together. Thank you.
Thanks, Team SkyVolt. I've got an easy question to start off. Since it's on the screen right now, how did you develop the logo?
Yeah, using OpenAI's DALL-E.
All right, moving into some more difficult questions. What is the projected difference between traditional refueling and electric charging? Could this accelerate plane turnaround?
So the current turnaround for a small aircraft, you have to do the whole cleaning and other preparation for flight. The current turnaround is about 30 minutes. According to metrics right now, to charge a plane for about a 250-mile flight, which is what we're aiming for, a 250 to 350-mile flight, is about 30 minutes as well. So while we may see a reduction with faster chargers in the development in future years, currently it's going to keep us going at exactly the same rate, so there will be no loss in time even with this move forward in technology.
Okay, thank you. You talked a little bit about your competition. Would you consider acquiring a company that is already in the market, someone that has existing infrastructure?
So our main kind of focus was really partnering with the people who are developing this charging infrastructure. We weren't able to identify anyone who had sites across different locations. That's kind of where we're positioning ourselves. We are looking to kind of onboard the manufacturers of the actual hardware as suppliers rather than acquiring them directly necessarily. So that's how we expect to approach it.
Do you see some synergies with the automotive level 3 rapid charging space?
Yeah, I think there's a lot of developments that have been pushed forward over the last, especially decade, in the automotive charging market, both in terms of de-risking what that power structure looks like, especially within the automotive level 3, which is up to 200 kilowatts right now, projected to be even higher than that. A lot of that space can definitely be expanded into the aircraft charging market, especially as the safety regulations for automotive are quite strict, and that is going to be very important moving forward for such high power charging on aircraft as well.
One more related to competition. Do you see Tesla becoming a competitor by providing charging stations?
Yeah. Again, that comes under kind of the established electric vehicle charging suppliers. They would be a competitor if they enter into the aviation market, but again, we're planning on being the first into the industry. So I mean, if they want to partner with us on something, then that would also be useful. But otherwise, I think we plan on establishing ourselves as the leaders in this field.
So with Tesla's charging infrastructure, their port actually for vehicles being what's brought up as the standard by the US government for charging infrastructure, that actually gives a good opportunity for partnerships. Because if they already have the infrastructure around the country and the technology for it, they might be a great partner for adopting this for another technology like air vehicles.
Very cool. So as you all know, and I'm sure everybody in the audience knows, this industry is full of regulations. How difficult do you believe it would be to work around regulations to bring this idea into reality?
So many of the companies in the space are already working with their legal teams and the government to address what sort of regulations are currently there or what needs to be addressed to actually create a safe environment for integrating short range hybrid and electric vehicles into the national airspace. So as an integrator and a comprehensive service provider, part of our arrangement with these companies is helping to ensure that these regulations are met and developing ones that are actually beneficial for the industry and keep our passengers safe.
Do you think it's better to go through FBOs already at airports or do standalone operations?
So part of the, go ahead.
I think one of the benefits of partnering with airports, especially initially, allows the infrastructure to be built out at a lower cost. It's going to be very capital intensive to build these out. That can be seen just from electric vehicle infrastructure. But as we move forward, the paradigm shift is going to change. How airports operate, both in terms of VTOL, vertical takeoff and landing, as well as integrating these electric charging is going to be critical where gates are, flight paths of vehicles, taxiways. So initially integrating directly with the facilities on site at airports and then expanding from there as the market changes.
One last question for you all. How do you ensure the 10% ROI for investors? And how can you guarantee that? Where and how was that number discovered?
So within our business model, we put in a few current things that we're going to be putting into contracts, as well as within our any contract we create with an airline, an airport, or other businesses that may be partnering with us. Currently, we have a plan for a startup fee with each airline, as well as a sort of subscription service to our electric charging stations that would bring in at least monthly income that is pretty standard to guarantee that 10%.
Also, we are offering maintenance service, which is standalone, like it doesn't have to be related to airlines or airports. So the customer will be dealing with the customer directly. So some of our margin also coming from there. And again, the airports and airlines are there. So we hope that would make at least 10%.
Okay.
Thanks.
Thank you. Thanks, Team SkyVolt. Our next team will be discussing space debris. Please welcome to the stage Team SCARAB.
All right, so at this very moment, there are over 8,000 operational satellites orbiting the Earth. Now, that number is amazing, but it's also been bringing about a smaller, more sinister issue. With this increase in operational satellites, we can see a direct predicted increase in the number of dead or defunct satellites that will continue to clutter the night sky. Now, there are companies with the ideas of servicing satellites in orbit to extend their lifetime, but there are currently no major initiatives to reuse these satellites once they are dead in the water, or in our case, dead in space. That's where we come about. We are the Satellite Component and Aerospace Resource Agglomeration Belt Initiative. Now, I know that's a mouthful, so you can just call us SCARAB. And we have the idea to turn satellite and space debris from a liability into an asset.
And we expect the number of satellites to go from 8,000 in 2023 to about 60,000 by 2030. And the collision damage and orbital debris loss is predicted to be about $86 to $103 million just in 2020. Now, the current regulations are to deorbit these satellites at the end of their life, but who's going to be responsible for this cleanup? We need someone who thinks of the debris as a resource, not a liability. And
we need to clean up.
Once a satellite has been designated as an end-of-life candidate for our service, SCARAB will send a transfer vehicle to grab that satellite from its initial orbit and move it to a depot orbit further out in MEO or GEO orbit for processing. Once there, a SCARAB on-orbit tender platform will disassemble, reclaim, and then sort and store the components and resources for eventual on-orbit assembly and manufacturing. As an example, assuming a 25% reclamation and reuse rate from a large satellite constellation, we can expect about $3.6 billion of materials to be available for further utilization. In addition, companies that utilize our on-orbit assembly services will save as much as $14 billion total costs in launch.
What we offer for our customers is a potential lifespan increase of their satellites. If you are planning to launch a satellite or you already have one in space, you must have some fuel reserved for the orbiting. Now, suppose you could use this fuel for your mission extension. As an example, Starlink satellites could have up to 5-fold their lifetime increase. Consider the stakes. The space industry is worth more than $500 billion. And it's not only business. We're securing our future in space. What goes for us? Well, we collect all the material for future reuse and repurpose.
Taking a look at some of our competition and alternative solutions, the first one, most common in the industry, is deorbiting. However, there is a 5 to 25-year regulatory timeline for this solution. There are also some upper atmospheric concerns as they burn up in the atmosphere, causing possible environmental impacts. The second is a graveyard orbit, where satellites are launched beyond geosynchronous orbit for storage when they are no longer functional. However, at this altitude, they can last there in orbit for eternity. This could also congest orbits for future mission plans. The third are avoidance systems, using attitude control mechanisms and maneuvers to avoid incoming satellites. However, this does not actively decrease orbit crowding, and it is not 100% reliable. Our solution ensures that components can be reused and extended the life of satellites.
Finally, our action plan, what we need from you, from customers, as large satellite service providers, is to create partnerships to clean up their satellite constellations at end-of-life disposal. And from these partnerships would come the funding to actually create a technology necessary for the cleanup and the repurposing of the materials. Also, we will need from the government to designate a depot orbit specifically for reclamation and to offer incentives and subsidies for on-orbit assembly with recycled satellite materials. And with this, if you're going to build on orbit, you're going to have the materials already with you there. So thank you very much.
And with that, we'll take any questions.
Thank you, Team SCARAB. I appreciate you not making me say every single word of SCARAB. Have you thought about repurposing debris for raw materials on a lunar base?
That was one of our initial motivations because it takes so much energy to launch every ounce of material from Earth to orbit, and then why waste all that and bring it down? So if we keep it in a graveyard orbit, then it is easier to move it from MEO or GEO to the moon than to launch it from Earth to LEO or low Earth orbit.
And just an example, when you think about something like Starship, where SpaceX plans to send vehicles to orbit constantly to refuel their capsules, that type of technology can very easily be transferred into grabbing these materials and therefore moving them from an Earth orbit to a lunar orbit or even Mars and beyond.
In terms of component reuse, how do you ensure component compatibility? Will your initial focus be on servicing common buses?
So one of our initial focuses is on operators of large satellite constellations. And one of the reasons we focused on that was because of the interchangeability and the standardization, which will make the development of the initial technology a lot more straightforward and streamlined. Once we have that initial technology base, we can diversify to more types of satellite buses and components. A salvage operation would also likely include a testing procedure for determining which components are still viable, and a sorting procedure for putting those in accessible locations.
How often will your in-orbit services need maintenance? What is your plan for long-term sustainment?
I think that's probably me as well. That would be something we'd need to reassess as the technology matures. At this early stage in development, we're not certain of the lifetime of our systems and components.
Do you envision raw material reclamation and fabrication, or is your current focus on replacing whole components with others?
Could you repeat the question?
Sure. Do you envision raw material reclamation and fabrication, or is your current focus on replacing whole components?
So for the moment, easier would be to reuse the components, but in future, indeed, like in our pictures, we would consider it reclaiming the raw components, so metals, semiconductors, and these sort of materials.
What kind of tugs, especially propulsion systems, do you envision to support these operations?
Well, this should be low thrust options because these are most efficient in terms of mass, fuel mass needed. So electric propulsion systems and similar.
One last question. $14 billion in launch cost is a bit vague. To put in context, is that number based on a certain number of launches?
So that number was based on, we took Starlink, the Starlink constellation as an example, and multiplied the number of kilograms needed for a total constellation by the number of pounds in that constellation. And then assuming the 25% reclamation, that would equate to the amount of poundage multiplied by the launch cost, which gives us about that $14 billion number.
All right, that is all the time we have for questions today, so thank you, Team SCARAB. Our next team today will be discussing space exploration. Please welcome to the stage Team Space for Earth.
Hello. Welcome, everyone, to the year 2024, which, for most of us, will be the coldest year of the rest of our lives. Climate change is undeniable, and it's important that we as a society tackle that with everything that we have. So where does space exploration fit into all this? Well, this picture, taken by Apollo 8 astronauts, is often credited as inspiring the environmentalist movement. But that was over 50 years ago. So where are we now? Well, there's a few things that we think we want to address when it comes to space exploration. Two in particular. The first, when it comes to food insecurity. Over the past even just 2 years, this has almost doubled or even tripled to over 300 million people across the world. And many of our ecosystems are facing collapse as we face the 6th greatest global extinction event. So, when it comes to space exploration, it's important for us to start focusing more directly on regenerative life support systems.
It is a fact that society benefits from space and space exploration applications. However, in this context, it is surprising that we don't find the interest in space exploration within the Sustainable Development Goals within the Agenda 2030, as society doesn't care about space. Therefore, disconnect between space exploration, research, and everyday problems we have identified as our limiting factor to address our need to reframe space exploration research towards societal problems.
To bridge the gap between space exploration and societal values, our approach aims to reduce to advance the research on bioregenerative life support systems, which essentially are technologies which are designed to emulate the Earth's the Earth's ecosystem. So they're designed to create a sustainable and self-sufficient environment that supports human life, especially in planetary exploration. In this system, biological organisms such as plants, microorganisms, and other life organisms are incorporated in a controlled environment, and in a controlled environment that simulates Earth. This integration establishes a closed loop for crucial life support functions such as air rejuvenation, water recycling, and food production, which is the ultimate aim to reduce and eliminate the frequent resupply from Earth. The main goal is to establish the relevance of these systems to both space exploration and our societal needs, such as dealing with climate change. By emphasizing the dual impact of BLSSS, we aim to shift the narrative of space exploration.
These technologies hold a significant benefit to society's progress. In fact, the Chinese Astronaut Research Center conducted an experiment in 2016 and was able to achieve a 100% regeneration of oxygen and 70% regeneration of food. The autonomy is crucial for extended space missions where resupplying from Earth may not be feasible. Extended space missions help society in two main areas. The first is technology transfer. Innovations in closed-loop technologies can be adapted for terrestrial application and pharmaceutical research. The second is commercial opportunities. Studies reveal that for every dollar invested in the Apollo program, the United States economy returned $5 to $7. There's also two main sets of costs associated with these missions. The first is habitat, launch, and infrastructure costs. Designing and building habitats, greenhouses, and other necessary infrastructure suitable for lunar conditions requires extensive engineering and construction. The second is operational and maintenance costs. The ongoing operational and maintenance costs for lunar agriculture are both extensive.
So what are other options for us when we're designing our exploration systems? Well, the first one that we're most familiar with is Earth resupply, and we've been doing that pretty consistently with the ISS. However, this can be expensive, prone to failure, and in a case of contingency situations, takes too much time. We can also be self-stocked, and that's what the Apollo missions did. However, as the Apollo 13 astronauts learned when they tried to fit a square peg in a round hole, this can be very inflexible. And as anyone who's eaten canned food for a while can tell you, quite unappealing. Third is in situ resource utilization, which is a key component for many of our planetary exploration systems. However, this is very expensive, very much untested, and especially when it comes to things like space dust, very disruptive to operations.
So what specific actions can NASA and policymakers take to make sure that we essentially bridge the gap between what is happening in the status quo and what we want the future of space exploration to be? If we look at the NASA budget in the fiscal year 2024, we can see that funding for specific departments that have the potential to support this bioregenerative life support system research was very low. So we propose and encourage political investments into these specific departments to expedite R&D initiatives in this research. In addition to this, we encourage NASA to augment partnerships with the commercial space industry. Currently, a lot of space industry research in the commercial side has to do with ag tech that's based on Earth, i.e. satellites that are used for agricultural purposes, for example. However, we would like to expand this and encourage these commercial space industries for research in bioregenerative life support systems, and this can be done in a twofold way. The first is by introducing short-term research on the International Space Station and analog environment. This enables us to begin this research into how these systems can work in microgravity, and in the future, the second part of this plan is infrastructural development. How do we make this a more robust and sustainable system in order to truly bridge the gap between space and Earth? Thank you.
Thank you, team. First question here, how do you feel existing research could be better leveraged or presented to the public?
Well, so there's been a lot of ongoing research in the International Space Station for onboard farming. And this is very, very fundamental towards some of our approaches because it's seen that, for one, astronauts love doing it. It's something they really enjoy cultivating. And it actually makes them happier. And that's one of those big challenges when it comes to space exploration is how do I keep our astronauts healthy, happy, and productive? And how do we get that message out? I think that comes down to better public engagement plans, working with people who aren't necessarily us. You know, we're already here, we're in the room, and we're the people who are pretty much already sold about the idea. So we need to work with other communities, especially disadvantaged communities, to make sure that they understand the benefits that some of this out-of-this-world research is providing.
Building a little bit off of the happy, healthy, and productive astronauts, how would you ensure the mental health of astronauts on long-term missions such as Mars colonies?
So a lot of research has actually gone into AI technologies that can be used to help with the mental health of astronauts, and I think that's also something that can be used in the same way that we're using space exploration for Earth benefits. So for example, there's a lot of new space versions of things like stuffed animals being created that you can actually have conversations with because they have AI and machine learning applications built into them. And we can use these applications that we're using for the mental health of astronauts and actually implement that on Earth too, for people that, for example, live in elderly communities where they don't necessarily have someone to have a conversation with every day. And so we can use those technologies not only for life support systems, but also mental health systems.
How will you replicate hostile environments like the surface of Mars to ensure your research is applicable?
That's a big challenge, and that I think is one of those things that we need to focus our research towards. I think most of us have seen The Martian, right? We can think about what the soil is made of, and we have good analogs for that. But I think part of it also comes down to understanding our own planet and building off of what we know here, and so that when we go to Mars, when we go to those foreign environments, we already have that knowledge with us.
May I add on? Yeah, and exactly as a solution for that question, the importance of space exploration is, I think crucial to mention as from data from the rovers that has been sent to Mars. We are collecting and we have received valuable data to create very similar analog space environments where we could simulate, for example, the surface.
All right, thank you. That is all the time we have for questions. Thank you. Our next team will be discussing sustainability. Please welcome Team REECycle to the stage.
Good afternoon. We are Team REECycle. Reduce, reuse, recycle, the motto of the 21st century. How does this apply to the aerospace industry, where single-use products are the name of the game? We are able to recycle 85% of an aircraft, including the avionics. In contrast, 1% of the rare earth metals in post-consumer products are returned to the manufacturing stream. Imagine a world where the industry designs for disassembly and recaptures critical materials in our products at the end of their service life. We can create opportunities to turn these materials into profitable outflows to other industries or even back into our own industry.
Why should we pursue this vision? Global demand for rare earth elements is expected to increase 3 to 7 times by 2040. And lithium alone is set to increase by a factor of 40. This is at a time when the supply for these materials is rapidly decreasing. These elements are essential in many aerospace technologies, and new solutions to attain them are necessary to continue production as we know it. When these technologies reach the end of their original use, they potentially can be recycled. This solution may involve larger upfront costs. However, the long-term benefit will allow this industry to continue to advance in the face of these upcoming shortages. The bottom line is that we need to invest in sustainable manners to obtain rare earth elements and critical metals.
Thank you. The approach involves recycling old avionics, batteries, etc. to extract rare earth elements. Additionally, emphasis on planning on end-of-life recycling and repurposing during the design and modeling phase of new products in aerospace industry is required. The utilization of rare earth metals extends beyond aerospace and defense sector and encompasses other sectors such as medical, automotive, energy, telecommunication, and computing. And therefore, collaborating with these sectors is crucial to broaden our vision for recycling. Evidence and feasibility of such idea is already demonstrated by few companies such as Novion Magnets, which reestablishing domestic capability for rare earth element separation and repurposing those materials to make neodymium iron boron magnets. There's another company, Tidbit, which is extracting rare earth elements from discarded disk drive magnets, and Service Solutions has partnered with Toyota to recycle lithium batteries with an impressive repurposing rate of 95%. So, what is needed? Training manpower to comprehend recycling, reusing, and repurposing, while emphasizing on designing for disassembly and also incorporating research and development to integrate existing technology for recycling, and also exploring new materials devised from recycled rare earth elements.
The benefits to you are twofold and allow you to build profits and public perception from both sides, reducing costs and increasing revenue. Electronics and supporting battery disposal can cost $1 to $2 per pound. Through design for reuse, what was once a liability on your balance sheet can become a new market and sell for as much as $33 per pound. Beyond this, parts that no longer meet aerospace certification can be sold in whole in other markets such as healthcare or construction. Some costs to consider are the introduction of an additional design consideration and the oversight of secure data destruction, something that your company is already doing for traditional disposal.
The primary alternative to reusing or recycling old parts is to dispose of them by mutilating parts beyond repair in accordance with FAA or local regulations. The parts that are not destroyed are sometimes given a new life in other vehicles or applications. However, when they reach the end of their second life, these parts still can be recycled. Letting aerospace technology sit in a boneyard or on a shelf is not only a lost opportunity, but it leads to a cost in waste removal instead of an investment in recycling.
So, how can you help? Consider the following. If you are a designer, use modular architectures and design for disassembly. If you are an MRO, maximize recycling in your demilitarization, end of life, and harbor refresh plants. If you are a regulator, support pilot facilities and make recycling an industry standard. With scale, we can reduce costs together. Let's bring the outside in as we make outflows become inflows. Thank you. We will now open the floor to questions.
Thank you, Team REECycle. So, rare earth metals are often intertwined into many electronic systems. How will you reclaim materials embedded in electronics?
So there are a variety of different methods in the different competitors we've discussed. And by and large, it is a process of grinding it down, which also has nice synergies with the data destruction in the defense and aerospace sectors. And then from there, when you have smaller and smaller components, you can then leach out the materials or pick out specific components from those boards that have naturally higher concentrations of the metals we are looking for. And so there are a variety, we plan to partner with a variety of different existing recycling companies if it comes to that.
You gave a few examples of industries that could reuse these reclaimed metals. Could you give an example of a second life in the medical industry?
Yeah, so if I heard the question correctly, it's can you give an example of where things are already reused in another industry?
Yes, they're asking specifically about the medical industry.
Okay, yeah. So one example is we're all aware of the certification environment in aerospace, and a lot of these tools that no longer meet aerospace requirements are perfectly fine in other industries that have different requirements. And so it can be a relatively low processing cost to take these components that were used on airplanes for other places, such as medical and monitoring equipment, surgical robots, that kind of thing, that use these rare earth elements as well.
Okay. Does the grinding of materials create environmental hazards that may be more harmful?
So there are some environmental impacts from current processes used to recycle the rare earth elements, but we came across numerous techniques that have been newly developed that are much more environmentally friendly and still quite efficient and cost-effective, like bioadaptive technologies and copper salt a copper salt mechanism. So those are really interesting technologies that we'd like to use going forward.
Tell me a little bit more about your team name. Why the double E?
So it's rare earth elements, so REECycle.
Makes sense. It's a simple answer.
And it's actually already a company name, which we only realized this morning.
That's okay. Maybe they'll bring you into their company. Does Second Life processing reduce the performance of rare earth metals?
So one of the companies you mentioned actually says that they repurpose 99.5% of the neodymium into magnets, and they're just as strong as the existing magnets. And they're a fully US-based company and do everything with US materials, and they make it all work. So it is definitely possible. Some redesign may be required in some cases, but other times engineers can be very creative to get every inch of performance out of the recycled materials. So it really depends on what you're recycling. But for metals, you can melt them down, bring them right back up, into different properties that you want.
Does the upfront cost of recycling reduce the overall revenue from recycling?
So with any industrial process, there will be investment, the capital cost investment earlier, but we think that there's a larger potential cost avoidance from not having these materials in the first place. And you can't get revenue if you can't build your fighter jet or your satellite or whatever. So if you can't build it in the first place, you're losing revenue. So we think there's more potential upside to this by securing your supply chain.
Public relations is also a really big part of this. A circular process is very beneficial to business and good business practices in this century, and so creating more circular processes is positive overall.
All right, that is all the time we have today, so thank you, Team REECycle. Just put them on. Last but not least, our next team will be discussing the future of aerospace and business issues. Please welcome to the stage RapidReg.
Good afternoon. We are RapidReg, and we are so excited to introduce you today to Rob, a regulation optimization bot. So, if we could cut the schedule and labor costs needed to grant regulatory approval in half, what else could your organizations achieve? Whatever revolutionary capabilities the future may hold, and whether you are on the regulation side or the ones inventing them, we want to help you get there faster.
We're entering a golden age in the aerospace industry where there's a proliferation of new players as well as new technologies. And as these new technologies are developed, they often diverge from the existing technologies on which existing regulations were based. So to cite an example from outside the aerospace industry, we have a robotic vehicle here, a robotic delivery vehicle that got held up for quite some time in the regulatory approval process because it did not have rear view mirrors. That is a robotic vehicle that got caught up in regulatory approval because it did not have rear view mirrors. So clearly there is a growing disconnect between the intent of the regulations and the new technologies that are going through the approval process. At the same time, we recognize there's an importance to having those regulations to maintain the safety of the public. But really the crux of the problem is that technologies get to the point of being ready for flight, but this mapping an existing approval process to new technologies can take years. It can involve a significantly increased effort on the part of the regulators. So to summarize all of that, the industry needs a way to accelerate the approval process without compromising safety. And to achieve this, we'd like to introduce Rob.
So Rob is our regulation optimization bot that uses generative AI to identify the purpose of existing regulations and to propose new, clearer regulations that will help you achieve your goals as a company. What does it do? So it receives an existing regulation and it compares it with existing, with a historical database of regulations, trying to identify the purpose of this new regulation. Once it has identified the purpose, it summarizes it up, and this summary process is supervised by an expert regulator until it generates an outcome that is satisfactory for it. Once this is done, it provides a new regulation, which is, of course, also supervised with a human in the loop with the existing regulatory authority until it converts to a new, clearer regulation. Now let us introduce the benefits of this new approach.
So for the benefits for our regulators, it allows them to reduce the labor required for approval process, as they don't have to go to a backlog of information, but they're always kept in the updated loop of how regulatory information forms. And for our technology teams, it allows our technology teams to gain an understanding of how regulations apply to a certain technology without the need to acquire regulatory expertise, which reduces the expense. And for our business partners, it allows them to accelerate new technologies to the market much faster.
So our competition is consulting firms who usher technical teams through existing regulatory approval, and lobbying firms who reach out directly to policymakers to update the regulations.
Yeah, so where do we go from here? The first step is to complete a minimum viable experiment where we're using Rob to review a specific requirement and iterating until it discovers the intent of the requirement as judged by a regulator. Next, we'll want to actually partner with a regulatory agency and have Rob review regulation and suggest amendments. And that step of the validation will be completed when Rob has successfully recommended an amendment, and that is approved by the amendment committee. Past that, we will integrate Rob into the approval process for these regulatory agencies, ideally decreasing the review and approval time by 2x.
So overall, whether you are the regulating authority or an innovator, we would love to try, or innovator trying to comply with regulations, we would love for you to join us, RapidReg, as we build Rob to help you cut your approval timelines in half. And we will give a special shout out to Zweifel. We would love to help you tackle all of your regulatory hurdles to help innovate your business and go even faster. Thank you.
Thank you, team. We've got a few questions rolling in. This first one, you probably have predicted that this would come in. So AI has proven to not always be reliable. What metrics must be implemented to begin implicitly trusting AI in sensitive applications?
So we recognize that not only our innovators, but also our regulating authorities might not trust an AI tool yet. And that's why our minimum viable experiment is so important. We're going to have a human in the loop and start training Rob on previous aircraft accidents, on our regulations, and how they came into being. So if something new changed in 2017 because of something that had happened in the industry, Rob will learn to understand that the intent of that regulation is based in a very specific safety accident. And so we want to use that one intent and that one regulation to help build confidence with both our customers and the regulating authorities that he is capable of both looking at these regulations from a safety perspective and from a regulation intent perspective, ensure that everything going forward will still meet both of those.
So if I can add something, keep in mind that we are having 2 layers of security. So on the first step, Rob is generating the intent or a summary of the new legislation, so that this is already supervised. And then the new regulation is also supervised again by the regulator or regulatory authority. So at the end, we estimate that with these 2 security layers, it's enough to keep AI, let's say, under control.
Perhaps you could expand a little bit more. So Rob will learn from the lessons learned in our past, but codes and regulations are not always static. What are your plans to evolve your platform as the rules change?
Yeah, so that's, I think, actually a really interesting illustration of the power of Rob. So we, have a much larger exercise when we're first reviewing and updating a regulation the first time around. with the regulatory authority very much in the loop. But then that's a great, insight that as the field evolves, as technologies are implemented, the regulations will inevitably need to be updated. So, that is a kind of our final point on our approach is long-term, the regulations, Rob can much more quickly update existing regulations that it has simplified than create new regulations. And we would encourage regulators to, when they come up with new requirements for these new regulations, to include in ROB the context behind those requirements that will help train it on the intent as technologies evolve past that point.
Thank you. Outside of safety, what are some other risks associated with taking humans out of the regulatory loop?
Yeah, maybe this question is a bit aligned to the previous one. So we are actually not taking humans out of the regulatory process. We are actually enable humans to perform more efficiently like a regulatory process. So to develop more efficient regulations, not taking the control out of humans, but enabling them to overperform their current capabilities, being enabled by AI.
And building on that, this will be a very dramatic example, very clearly not technology that is ready right now. But if we have a company in 10 years that says we can now do teleportation and we're ready to go, and how the heck do we certify this? I don't think there's any regulators that really want to sit down and read every page of the FAA CFR Code of Regulations to see exactly which lines may be affected by teleportation technology and what lines do they have to go do. So we imagine that Rob can go and scour every regulating code that may be touched by a technology like teleportation and deliver all of those new updated regulations to those regulating authorities and say, hey, I already looked through all of your documents for you. Here's where I think you need to focus, and here's where you may need to update.
One last question here. How does Rob adapt to regulations across different countries?
So to adapt ROB to different countries' regulations, we have to have different versions of ROB that is appropriate with their regulations. So for each country, we have to develop its own version of, tailored version of ROB to actually address their regulations. Then it can understand and summarize or provide the intent of actual regulation.
Awesome. Thank you very much, Team RapidReg.
Thank you all.
As you can tell, our teams worked so hard to put together their presentations, and just in a few days. I'd like to thank them all for all of their hard work in preparing for the IDEA Challenge. Please give them another round of applause. I hope you all enjoyed this engaging discussion and are inspired by their thoughts and ideas. We encourage you to come up to the front to talk with them after this to see how we can bring these ideas to fruition. I'd also like to thank our mentors once again for their time and efforts in encouraging and guiding our teams. And I'd also like to thank our audience for joining us and for providing such excellent questions. As we close today, I'd like to note that we would like to hold the IDEA Challenge again next year. If you're interested in joining as a team member or mentor, we'd welcome your involvement. Please stay tuned for more information from AIAA. Thank you all and have a great rest of your day.